This is how's metabolomics now today. Yeah, you see that proteomics and genomics, they reached maximum in the number of publications. But you see that metabolomics is still growing very strongly. So we are now in an exponential phase, I think. So we expect that in a few years, metabolomics will be the most important omics around. In metabolomics, you can distinguish three phases in the research. If you look how metabolomics is done, it then be considered as determination of all compounds in the system. It's not just that. What you do is really metabolic fingerprinting, so you make an image of all, preferably all compounds, but then you are going to compare it. You want to see what are the differences. And after all, you want to know what is there to interpret really the differences. And that is really metabolomics. It involves all these three phases.
Thank you for your talk, and I want to ask you about which statistical method used to show similarity in NMR data.
Why do you need statistical method for that?
Oh, really?
Yeah, statistics have a lot of different samples. Yeah, you can do statistics. But in fact, this is just the number that comes out if you compare two spectra.
It's just the difference?
Yes. Yes.
Okay, thank you.
Yes.
I agree also that PCA is data reduction. I wonder if maybe a survey, is anybody doing random forest? Because this is predictive models, because you just discriminate and then you can predict. This is the power of random forest. Have you applied random forest?
No, I didn't apply it, and I'm not very familiar with it, in fact.
It's very powerful because you build a model on, and you can discriminate samples, and then you can predict unknown samples to which group they belong. So it's a predictive model.
Yes.
And then you can extract the importance of each variable.
Yes.
And you can, it's really powerful. I would recommend to everybody doing NMR to do random forest.
Yes.
But I have some doubt about that. Random forest is a very nice model, but always when you start metabolomics for the medicinal plant, you don't have a group. Actually, your group is not clear. For example, if you make a group good and bad, how can you decide which one is good and bad? If you have five geographical origin, but who knows next 10 years, 6 or 7 geographical origin. So his comment is if you have a very clear model, and second requirement, if you have enough number of samples, it's a very nice model. But always, if you have a very unclear model and then random approach, then random forest is rather, for me, I have doubt. We have some genuine cases. It's really whether it's a Korean ginseng or Chinese ginseng. Those two models we can apply, but other cases, I think it's a doubt.